Today on My Engineering Projects, we're going to get started with OLED displays using an Arduino, and then we'll build a very simple digital voltmeter. So here's our OLED display, and I paid about $6 each, and I bought a 2-pack, and I'll put a product link in the description below. So it's a 1.3 inch display, and it's got 128 by 64 pixels. So 128 in this direction and 64 pixels here. I bought a monochrome, but they also come in bicolor, and they also come bigger and smaller. But this one's about the right size for small projects where I need to display just a little bit of information. It's going to come with 4 header pins, and then you can solder those in. I did not use the header pins that was supplied with it because I wanted 90 degrees, so I soldered mine in the other direction. Now you can change the address by removing the resistor and changing it to a new position, but I'm going to leave mine just like it is. So this is the I2C protocol, and it has 4 pins, and we're going to go over those next. Okay, so let's hook up our OLED display. It's really pretty simple. So let's start from left to right from how mine is set up, and yours might be slightly different. The first pin is the ground pin, and we're simply going to connect this to the Arduino ground. The next pin is the VCC, or the input, and this can accept from 3 to 5 volts. The next pin is the SCLA, and this is the clock pin, and we're going to connect this to pin A5. The last pin is the SDA, which is the data port, and we'll connect this to pin A4, and note that they're reversed. So if you go from left to right on your board, it is not exactly left to right on your Arduino, so please make note of that. So I have the wires connected as I just described, and now it's time to test our OLED display. So the first thing you need to do is you need to add the library needed for your particular display. Now, originally I thought it needed the 1306 library because that's what it showed in the product description. But when I tried it, it didn't work, and then I went back and looked at and found the reviews, and it looks like that they have changed the library needed. So for my particular board, I needed the 1106. So if you go to Tools, Manage Libraries, and you type in the library that you need, for example, in my case, it's the 1106 library, and you're going to see something like this. This is a little bit misleading. It says SH110X. Basically, it's a range of from 1107 to 1106G, and that's the version that I needed for my particular one. But you may need the 1306, and if you do need the 1306, then there'll probably be some additional libraries that you need to load. And so here we have 2 sets of libraries. So make sure that you have all the libraries needed. Now each of these libraries are going to have an example sketch, and that's really the easiest way to get started. So if we go to File, Examples. Now let's go down to the very bottom, scroll down here to the 1106 library, and then we're going to go into this folder, and then they have 2 sketches. They've got the SPI and the I2C. So I chose the I2C because this is the protocol I'm using. And when we do this and then upload the sketch, then we can see if everything's going to work correctly. So after uploading the sketch, you should see something like this, at least if you're using the library that I use. And they're going to go through various capabilities and text and fonts and logos and whatnot. And so the resolution is probably something like you'd see on an older BlackBerry. It's not, the greatest, not like an iPhone, but it's decent, and it's clear enough that you can read even small text. Okay, so let's have a little bit of fun. Let's create a simple voltmeter that'll just read the voltage from 0 to 5 volts and show it on the screen. So using the other example as a template, we're going to include the required libraries, set the screen width and the address, and then do our setup function. Now that the setup is complete, we go into the loop. We're going to set the text size to 1, and this is an integer. It starts at 1 and 5, I believe. We can look that up if we need it. And we're going to set the color to white. And we'll do one line, and I didn't have quite enough room to put my engineering projects on 2 lines, so I just put my engineering and projects on the second line, and then I had a blank space. Now we're going to read A0, and this is an analog, so we have an A to D converter, and it goes from 0 to 1023, so 0 is 0 volts, and 1023 is 5 volts. So in order to get the voltage, we simply take 1023, 5 divided by 1023, and then we will convert what we read into an input voltage. And then we're going to print out volts, so the display print volts, and then display print line. This will concatenate volts and the voltage on a single line. And then we will display it and clear the display, the buffer and the display for the next loop. All right, let's go upload the sketch and take a look. Okay, so pin A0 is the positive and ground is the ground. So here we have 1.47 volts. Let's test this other battery. And here we have 1.27, and it's lower voltage because that's a nickel metal hydride. Now let's plug it back into the USB and we'll measure them again. Remember, the last one was 1.27 volts. And now we have 1.44. So the reason that that is inaccurate is because the USB is variable. And so it resets the 5 volt to the voltage coming in, which is incorrect because if we measured, it's actually about 4.6. So for the most accurate, disconnect the USB and allow the Arduino to regulate the voltage to the A0 pin.